Hello everybody, welcome to the third session of seafood canning technology. So mainly four metals are commonly used for the packaging of food. So that we have already discussed, like steel, aluminum, tin and chromium are the different kinds of four major materials that we use for food cans. Tin and steel and chromium and steel, these are two combinations. That basic, even though the basic material is steel, we use for the steel cans, there are two materials are used for coating. One is tin and one is chromium. So these are used as composite materials in the form of tin plate, or it can be this. Basically, it's called tin plate because if the tin is used, it's called tin plate, or the chromium is used, is called chromium plate or tin-free steel. So different kinds of terminologies are there. Either tin plate or it can be used as electrolytically chromium coated steel. Is called ECCS. Basically, two different types of steel containers used. One is tin steel and another one is chromium steel, and they are used as a composite materials in the form of tin plate, or whether the steel plate is coated with tin is called tin plate, or the if it is coated with chromium, it is called chromium plate, or it can another name also is referred to as tin free steel. Either tin plating or chromium coating are, there are two different methods that is generally used for coating. Initially hot dipping method was used, but now it is electrolytic deposition is used mostly for coating the steel base with different kinds of metals such as tin or chromium. So that is the case of steel cans. Steel cans can be coated either with tin or chromium. And in the case of aluminum, is used in the form of purified alloys, mixture of aluminum and other minerals. It containing small and carefully controlled amounts of magnesium and manganese. So in the case of aluminum sheet or metallic sheet of aluminum that is used for can making, particular percentage of magnesium and manganese are added to basically to regulate the physical properties of the container. So in the case of tin cans, different terminologies are used. Either tin can or steel can, different kinds of terminology. Steel can is a general terminology used for both tin coated steel and as well as chromium coated steel. Otherwise, it can be called as a tin can or a TFS, tin free steel can, or a chromium can. The term tin plate refers to low carbon mild steel sheet. It is basically lower carbon mild steel sheet varying in thickness. From the thickness is around 0.15 to zero point 0.5 mm with a coating of tin between 2.8 and 17 GSM. So the thickness is going to be 0.4 to 2.5 micrometer in thickness, and on each surface of the material. That is basically the material is 98% steel and 2% tin. That is a general general composition of a basic tin plate. It is around 98% steel and 2% tin. So the steel that we use is basically low carbon steel. So the percentage of carbon is maintained at 0.13 percentage, and also manganese is more than carbon. Manganese is 0.6 percentage, and phosphorus is 0.15 percentage, sulfur 0.05 percentage, silica 0.01 percentage, copper 0.06 percentage. So this is basically an average chemical composition of steel that is used for can making. So tin plate, basically the tin coated steel was first used in or developed in England in 1699, and also in France in 1720. And also the steel forms, steel, why it is called steel is basically an iron material. It's basically iron, but the difference is that in the case of carbon and manganese, which gives a particular properties to the particular iron. So in the case of strength, it increases the strength, increases the corrosion resistance. So stainless steel means it is up to 10% carbon. Stainless steel is one another type of steel that is used for cookery purposes in the case of kitchen and other materials, other usage. The stainless steel is up to 10% of carbon. So why low carbon? Why stainless steel is not used in the case of can making is that stainless steel basically the 10 percentage as the carbon percentage increases. That stainless steel we already told that is almost 10% of carbon. As the carbon percentage increases, the strength of the material, the rigidity of the material increases. So it is not flexible. So it is not suitable for can making. Can making involves various different kinds of flexible processes. That a can has to be like formed into cylinder shape. Different kinds of shapes has to be formed from that metallic sheet. So stainless steel is not an option for that. So that is why low carbon steel is used. So why low carbon steel is used? It gives more flexibility to the metal sheet, and also the quality, the grade. There are different grades in the case of that. MR quality grade is basically that one of the steel quality that is used for can making purposes. Here, what happens is that the phosphorus percentage is kept at a minimum, that is around 0.02 percentage. The percentage of phosphorus determines, because as the process increases, the percentage of phosphorus increases, the corrosiveness increases. This is the percentage of the phosphor has to be kept at a minimum, that is 0.02 percentage of phosphor. So why means it increases or reduces the corrosiveness, and it also increases the strength. So that is the ideal phosphorus percentage in the case of MR quality steel that we use. So the terminology, the base plate or the basic material, metallic sheet that we use for the formation of cans is known as base plate. Base plate is basically, it is a steel plate before tin application. The basic steel or low carbon steel sheet that we use for can making is called the base plate. So there are different types of steel produced for subsequent use in tin plate cans. For before coating the tin, that the different qualities of steels are used: D type, L type, MR type, and N type. Among this, the carbon is around 0.13 percentage to 12 percentage. So MR quality is what that is used for the canning purposes, and in the case of MR quality, the carbon percentage is 0.13 percentage, and as we told, manganese is 0.6, phosphorus is 0.02. Phosphorus is minimum in the case of MR grade. 0.0 sulfur and different kinds of silicon, copper, alumina, different kinds of materials are there. But the presence of manganese, magnesium, and phosphorus, these are the three mineral compositions that determines the different quality of the steel sheet. The preparation of the base plate is one of the important processes. So there are basically two methods in which the base steel plate can be used. There is cold reduction method or cold rolled method or a hot rolled method. So there is basically two types of sheets, steel sheets. One is cold rolled sheet and one is hot rolled sheet. So cold rolled is considered to be better than hot rolled, because hot rolling was the technique that is used in the earlier period, because it is basically rolling steel. The molten steel is rolled at high temperature. It is around 926 degrees Celsius. High temperatures used to roll the sheet. Because one of the advantage of hot rolled steel sheet is basically it is cheaper, and it is basically because of this low cost, it is used majorly, that kind of steel is used in the case of construction and welding industry. But the cold rolled sheets are further processed, because cold rolling technique gives it high finishing properties, and it has also high mechanical strength. More thinner plates with high mechanical strength can be produced using cold reduced or cold rolled steel sheet. And also it has uniform thickness compared to hot rolled. These are the advantages of cold rolled sheets compared to hot rolled sheets. So it has a high mechanical strength with thinner plate, uniform thickness is there, resistance to corrosion, that is one of the important properties. It takes uniform tin coating. When we, after the coating of the tin is done, it takes uniform tin coating. And also the appearance of the cold rolled sheet is much better than the hot rolled sheet. That is, these are the different advantages of cold rolling. And also, after a particular quality MR quality sheet, a steel sheet or base plate, low carbon base plate is prepared. MR quality low carbon base plate is prepared, either using mostly it will be used cold rolling method. So after preparing the sheet or preparing the base plate, the next procedure is basically coating it with either tin or chromium. The tin coating, earlier hot dipping method was used. Molten, it was the sheets, the base plates or basic steel sheets will be dipped in molten tin. But tin eventually, tin started to become expensive. So the quantity, the amount of tin coating or the thickness of the tin coating was eventually reduced. So basically, the most economical coating method, it is known as electroplating, was developed after that. So now for basic coating, electroplating method is used. For in the case of hot dipping, what happens is that base plate is basically placed into the molten tin, as we discussed before, and this, like the molten tin will be at a constant temperature, and then it is passed through a layer of palm oil to lubricate the process, and then squeezed through actually tin coated steel rollers. So this was the process followed in the case of hot dipping process. In the case of electroplating, the base plate is first cleaned and it is lightly pickled in like different kinds of acids are used, like H2SO4, sulfuric acid or hydrochloric acids are used, and it is passed through a series of electrolytic cells filled with dilute acid and alkali, and pure tin is used as the anode and base plate is used as the cathode. So in the cases, what happens is a direct current is passed. So intermediary, what happens is that the tin iron alloy is forced, like it's different kinds of the tin deposition is formed, because from cathode to anode there is an electrolytic, the movement of tin ions. So what happens is tin will get deposited at the anode. So what happens is a kind of tin iron alloy is formed, which is higher in corrosion resistance, is formed over the base plate. So it is chemically passive treatment by dipping in, either if you want to use chromium, either if it is a chromium oxide coating or other type of coating method, we can dip it in chromic acid or sodium chromate solution, washing, drying, then a thin coat of oil is applied, and these are the different processes in the case of electroplating. So electroplating is a much easier process. So what the advantage is that you will get a uniform layer of tin can be applied over the base plate. In the case of tin plate layers, if you take a cross section of a normal tin plate that is used for preparation of can containers, it will basically have the steel base. Steel base is the basic component. It will determine the strength and formability of the container, and tin iron alloy is basically formed. So the tin iron alloy that is formed by electroplating, it is an interface of steel and free tin layer, act as a band between two layers. At a tin iron alloy is formed between the tin layer and the iron layer, and the steel layer. So there are basically three layers. There is topmost will be a normal coating of tin, and the bottom in under the tin layer there will be a tin iron alloy, and under the tin iron alloy there will be the steel sheet. So this will be the various the cross sectional coating that will be happening in the case of a proper tin plate. And also there will be a chromium oxide layer which is called as oxide passivation layer, which prevents oxidation. So the chromium is also applied, and also another layer of oil film. So in the case of oil film, normally this dioctyl sebacate or acetyl tributyl citrate or ATC is used as an oil coating, and for easy handling and abrasion resistance. For easy handling means when this tin coated steel sheet is passed through different kinds of rollers and all while the formation of the cans, it should not wear off. So in the case of provide an abrasion resistance, this kind of oil film is additionally added as a lubricant. And there are different standard grades and masses or terminologies that is used. So in the case of tin plate sheets, the basic terminology is used as base box or BB. Base box means one base box is basically 112 sheets of 14 into 20 inches size. 1 pound of base box is basically 1 pound of tin on both sides. One pound of base box means 1 pound of tin on both sides. That means 0.5 pound on each side, or it's around 11.2 GSM, the amount of tin coating. And also in the case of electrolytically coated tin steel, or the grading system uses SITA. It is called System Intentional Tin Plate Area. So that is the grading system that is used for in the case of electrolytically coated tin sheet. That means around 100 meter square. One SITA is around 4.9426 base box. So different kinds of units are used. GSM is most commonly used in the case of coating to express the coating of tin. And also there are different kinds of coating. That is, one is even coating, is differential coating is there. Even coating means on the both the sides, for example 11.2 GSM of tin will be coated on both the sides. And differential coating means either the outside will have more tin coating and inside will have a lesser tin coating. So that is called differential coating. In the case of electrolytic chromium, that chromium coated steel or tin free steel cans, it is a different terminologies around. One is electrolytic chromium, it is also known as electrolytic chromium, or chromium oxide coated low carbon steel sheet, or it is known like ECCS or TFS, either ECCS or TFS. These are the two terminologies that we use for chromium coated steel. In the case of chromium, the base steel will be having around 200 micrometer of base steel will be having, and we will have a chromium layer. Chromium coating will be there. It is around 0.002 micrometer chromium coating. And also at the top of the chromium coating, we will have a chromium oxide layer which is 0.02 micrometer thickness. And finally, we will have a 0.004 micrometer thickness of oil that is used for lubrication and shiny appearance. Now we can discuss the different kinds of advantages and disadvantages of ECCS over tin plate, normal tin plate compared to TFS or ECCS. So basically advantages that the lacquer addition on this kind of ECCS is superior to tin plate, and resistance to underfilm, below the lacquer film corrosion is excellent. So that corrosion resistance is also good. Lacquer addition is better in the case of TFS cans. And also TFS cans are resistant to sulfide blackening. That is one of the spoilage that is happening in canning. And also TFS cans are the workability of enameled TFS cans superior to the tin plate. and lacquer adhesion strength remains even after deep drawing. Different kinds of deep drawing means the sheet can be drawn into different shapes without compromising the physical strength. And also TFS can does not contain low melting tin. The tin is not there. Hence, lacquering can be done at high temperature for a shorter period of time, because if we are using tin cans, the high temperature cannot be used. High temperature lacquering procedures cannot be used because it will compromise the tin coating. So, since in the case of TFS cans, there is no tin coating, high temperature lacquering is possible. And also, it is low cost compared to other plates for can manufacture, because TFS cans are cheaper than tin plates. But in the case of there are certain disadvantages also that is mentioned in the case of TFS cans. So in the case of TFS, surface film does not act as a sacrificial layer and prone to corrosion from outside. So TFS cans, if it does not be handled, so for that purpose, an additional layer of plastic layer or polyester layer coating is given in the case of TFS cans to prevent this additional corrosion resistance. That is one of the disadvantages. And unlacquered TFS is less resistant to corrosion than tin plates that we already mentioned. The corrosion resistance is a little bit less in the case of TFS cans. So that an additional layer of plastic layer has to be given in the case of TFS cans. Cans cannot be made by side seam soldering because TFS cans are not good for soldered cans, especially three-piece cans. So only two-piece cans can be successfully made from TFS steel. So this is some of the advantages and disadvantages of TFS compared to traditional tin plate. In the case of aluminum cans, aluminum, you can see that normal aluminum alloy is used and its composition limits, like other kinds of additives are used. So different purpose of use, different aluminum alloys are there. So different kinds of silicon is used, silica is used, iron, copper, manganese, magnesium, chromium, zinc, and different kinds of such kind of materials are used in the case of aluminum. So why copper is one of the important additive or component in the case of aluminum cans, because copper, what happens is copper reduces the corrosion resistance of aluminum more than any other alloying element. In the case of aluminum alloy that is used for canning, copper should be minimum. The copper in the case of aluminum cans, the aluminum sheet or aluminum metal that we are going to use for preparation of canning containers. So copper should be kept at minimum, because copper, if it is present at higher concentration, it will reduce. It's like it reduce corrosion resistance. So and also elements reduce high rate of general corrosion. The corrosion is one of the problem created by the higher concentration of copper. And manganese will also slightly increase corrosion. So manganese is tentatively a particular material which slightly increases the corrosion resistance. So manganese need to be put at a higher concentration in the case of canning cans. And magnesium has a beneficial influence, and aluminum magnesium alloys have good corrosion resistance. So both manganese and magnesium gives higher corrosion resistance to aluminum. So zinc, in the case of zinc, has only a small influence on corrosion resistance in most environments, tending to reduce the resistance of alloys to acid media and increase the resistance to alkali. So basically, the zinc will provide a resistance to acid alkali. So alkaline resistance is given by zinc. So each of this, for example, silicon basically slightly decreases corrosion resistance depending on its form and location in the alloy microstructure. So silicon is there. Chromium increases corrosion resistance, as we all know. Then iron also reduces corrosion resistance. Titanium is there, has little influence on corrosion resistance, and aluminum alloy. So these kinds of different minerals are there. So according to their property, all these like silica, iron, copper, manganese, magnesium, chromium, zinc, and titanium. These are the different kinds of mineral components that is normally found in the case of aluminum sheet, aluminum metal sheet, which is used for canning. So according to their properties, those mineral components that will reduce the corrosion resistance has to be kept at minimum, and which mineral components that actually increases the corrosion resistance has to be kept at a higher concentration uh, other than aluminum. So that is the basic, that is combination that we use in the case of aluminum containers. So aluminum is one of the most abundant metal, as you know. It contributes around 8.8 percentage of earth crust rich in aluminum, and the aluminum ore that we use is bauxite. Bauxites are basically a group of aluminum oxides, alumina that we use, sand alumina that we had discussed, aluminum with iron and silica impurities. So aluminum alone does not have many properties. That is why we use an array of mineral components, because aluminum alone does not have many properties for packaging. So different kinds of alloying agents are needs to be added that we have discussed. So unalloyed aluminum, which is called 1050, used for foil and other kinds of containers, like foil containers. Aluminum foil is basically pure aluminum because it is very highly fragile. So basically, manganese and magnesium are added for giving strength to the aluminum containers. Then advantages of aluminum as a food cannon. There are different kinds of advantages as well as any container material will have both advantage and disadvantage. So in the case of we consider about aluminum containers, advantages are aluminum does not impart any taste or flavor. It is completely bland. It is completely neutral towards the food and hence suitable for delicately flavored products such as soft drinks and beer. That is why in the case of beverage cans, beverage containers, why aluminum is used. Aluminum does not impart any flavor to the food. So aluminum is that is one of the advantages of aluminum. And so aluminum does not contain sulfur, so it does not have any sulfide staining or blackening. The iron is not there, so iron will not react with the sulfur containing amino acids. So there is no sulfur staining or sulfide blackening is going to happen. Aluminum is soft and workability is very good, highly flexible, as we know. The power requirement during drawing and processing is less because of the flexibility of the aluminum, and it is lightweight. That is these are the among the advantages of aluminum, and there are certain disadvantages as well. So disadvantages are it is poor resistance to acid and chloride containing products and has hence highest integrity of lacquer or protective coating is required. So aluminum cans does not have any resistance towards acid, foods or chlorine. So a higher coating of lacquer coating is required to protect the aluminum containers. Cost is very high. Aluminum containers are very high in cost. So that is why only in the case of beverage cans aluminum is used, not in the case of solid food cans. Because in the case of beverage cans, the amount of metal required is very less. So manufacturers can afford aluminum. But in the case of solid food cans or fish cans, seafood cans, the amount of metal is more. So it will eventually increase the cost of the product. So cost is very high. And also aluminum has weak mechanical properties and requires overpressure retort for heat processing. So aluminum containers, even though it is considered as a rigid material, but it cannot withstand high pressure. So what happens is that we need to withstand actually when it is heated, it cannot withstand the internal expansion pressure. So what happens is that while processing aluminum cans, unlike either TFS cans or tin plate cans, another additional overpressure need to be provided in the retort so that it will not bulge. So that kind of physical strength is lacking in the case of aluminum. So this is the basically the advantage and disadvantage of aluminum containers.
Thank you.